we're going to continue talking about coordinate notation for reflection. And just like with translation, coordinate notation allows you to describe a reflection using symbols instead of words. We will write the coordinate notation only for reflections across the x and y axes. Even though, yes, reflections can be done across any line, we are only going to be writing the coordinate notation for reflections across x and y axes. We are going to start with this example here. We have a trapezoid, PQRS, and we are going to reflect it across the x-axis. And so recall from our previous lesson that to reflect, all you are doing is matching the distances to and from your line of reflection. So for example, if we look at point P right there is 1, 2, 3 units above the line of reflection, so we match it below 1, 2, 3 units below. So that is going to be your P prime, and if we label everything else, this is going to be S prime, R prime up here, and then Q prime right on over there. So now let's take a look at your pre-image and image coordinates and see how they changed. So again, let's just kind of break it down, look at your x coordinates, and then look at your y coordinates separately. So let's investigate the x coordinates right there of each one of those points. All right, and then compare it to your x coordinates of your image. What do you notice? You should see that they are exactly the same. Nothing changed. So we're going to make note, again, that our x coordinates stay exactly the same. Let's see what happens with our y coordinates. So y coordinates for your pre-image, and then y coordinates for your image. What do you notice? You should see that, well, 3 becomes -3, 1 becomes -1, 1 becomes -1, 3 becomes -3, so it is becoming the exact opposite. So we're going to make note here that the y coordinates become the opposite. And that should make sense. Look at your figure, right? If you are reflecting it across the x-axis, right, that means that you're just moving something from the top to the bottom, or from the bottom to the top, right? So your x values, your horizontal values, do not change. It is going to just be your vertical values, your up and down. So that is why your y values are the only values that change. So now let's see if we can describe this using coordinate notation, right? So of course, we always start with your original coordinates, x comma y. They are going to change. They are going to become new coordinates. And so how do they change? So note that your x coordinate doesn't change at all. It stays as x. So x remains as x. Comma, how do your y coordinates change? Y coordinates become the opposite, right? So to symbolize the opposite, we would have the negative sign. So whatever it is, it becomes the opposite of what it is. Okay, now let's look at a reflection across the y-axis. Okay, so you have the same figure, same trapezoid, PQRS. Now I've reflected across the y-axis. Again, just to recall how we do this, all we're doing is matching distances. So let's look at point R here. R is 1, 2 units on the left. We are going to match that on the right. So 1, 2 units on the right. So this is going to be your R prime. And if we fill in the rest, Q prime here, this is going to be S prime, and then P prime. Now let's focus on our coordinates. So we have our pre-image coordinates and our image coordinates. Again, let's look at x and y coordinates separately. Let's investigate the x first. So here are the x coordinates of those points for your pre-image. Here are the x coordinates for your image points. And so what do you notice? -5 becomes +5, -4 becomes +4, -2 becomes +2, and -1 becomes +1. So that means this time around, your x values are becoming the opposite. All right, so we've made a note of that there. X coordinates become the opposite. Let's investigate your y coordinates. So here are the y coordinates of your pre-image. Here are the y coordinates of your image. This one should be easier to figure out. What happens to the y coordinates? Nothing. It stays exactly the same. So we've made note of that there. Y coordinates stayed the same. And again, if you look at your figure, if you are reflecting it across the y-axis, right, you are moving something from the left to the right or something from the right to the left. And so there's a horizontal change there and no vertical change. That's why your y stayed the same. Your x's are changing this time. So now let's see if we can describe this using coordinate notation. All right, so again, we start with your original x comma y. It is going to become new coordinates. What are those new coordinates? Let's look at your x. X becomes the opposite. And to represent that, it is going to be negative or minus x, comma, y stays the same. So y is just going to be y. And there's your coordinate notation for reflection across the y-axis. So let's recap here. There's really only two coordinate notations you need to know for reflection, right? Reflection across the x-axis, x comma y becomes x comma negative y, right? So just remember that if you're reflecting across the x-axis, x stays the same, right? And then reflection across the y-axis, x comma y becomes negative x comma y. Same thing. Reflection across the y-axis, y stays the same. All right. And again, just be careful. The negative, so just like right here, negative y does not mean that everything becomes negative. This is telling you that it becomes the opposite. Okay, so be careful with that. It's not that everything becomes negative, it becomes the opposite. Right. So here's just a quick little example to practice everything that we've talked about. It says, find the new coordinates for the pre-image point 4, negative 5 after these series of transformations. So the first thing you're going to do is you are going to translate it 3 units to the left, 7 units down. Using what we've learned about coordinate notation for translation, right? 3 units to the left means that you're taking your x coordinate and subtracting 3 from that. 7 units down means that you're taking your y coordinates and subtracting 7 from that. So your starting coordinates for negative 5 is going to change. It is going to become new coordinates, right? So you take the original x value and you're going to subtract 3 from it. You take your original y value and you're going to subtract 7 from that. And what does that give you? 4 minus 3 is 1, and negative 5 minus 7 is a negative 12. So now, after the translation, we are at the new coordinates 1, negative 12. What we're going to do with that is we are going to reflect it across the y-axis. So the coordinate notation for reflection across the y-axis tells you that your original coordinates, x, y, is going to change, and your x values become the opposite. Your y values stay the same. So we are going to take 1, negative 12. We are going to change that. Alright, so that means the x-coordinate becomes the opposite, so negative 1. And then your y-coordinates stay exactly the same, so it is going to be negative 12. So that means your new coordinates is negative 1, negative 12. And you're done.